So, second day of dealing with things in quadratic form, which means there's no parentheses involved. So, here's an equation that I'd have. Here's something I could graph with a parabola. So, reminder, to find the vertex, to find the x value, we use that little mini fraction, negative b over 2a. So, when I go trying to use that here, never hurts to label my a, my b, and my c values. So my a would be 2, the number in front of x squared. My b would be negative 4, the number in front of x. My c is the number on the end, which in this case would also be negative 4. So here, negative, or the opposite of b, since b is negative 4, I'd use positive 4. And then over 2 times my a value. So over 2 times 2. So if I simplify that, 2 times 2 is 4. And 4 divided by 4 is 1. Okay, that gets me the x value of my vertex. But that isn't all I need, of course, because a vertex is a coordinate. I need to know what y equals. So, once I get that x value set, we're going to plug that x value into my y equals equation. Now at this point, I have choices. One of my choices would be to use the graphing calculator, type in the equation, find x equals 1, and go from there. But I'm also going to do it manually here. So this is sort of like, we'll call this B1. So what I'm going to do here is I'm going to go through, and every time I get to an x, I'm going to replace it with my x value. Just to show you that there's more than one way on a lot of these to make this work. Now, if you're comfortable doing that math on your own, you can. If you're like, not quite so sure on this one, okay. We also can go ahead and say, okay, so we'll show you both ways to tackle this guy. And this would work whether I had a scientific calculator, one like this, doesn't really matter. Okay, so I notice it says, all right, negative 6. So that would mean my vertex is at 1, negative 6. Now, let's just say we wanted to make sure we didn't really trust ourselves with this. My other option would be to go to y equals, okay, get anything cleared out that's already there. Type in my expression, make sure I got all my signs right and everything. And I could pull up my table. So second graph, so these two. And what I would do is I'd look to get that 1 in the middle and check out the y value, negative 6. Okay? I can do it that way too. And I see my symmetry. And I'll come back to that in a minute because that'll help us with the graphing part. Speaking of, my axis of symmetry is x equals 1, which is the same as the x value of my vertex. So this and this will always be the same. Lots of connections with these. My y-intercept in standard form is going to be 0 and c. 0 and whatever this value is. So my y-intercept is 0, negative 4. But we've also talked about how the y-intercept just occurs when x equals 0. So if I were to look at my calculator, I had the chart up, go to where x equals 0. Oh, there's the y-intercept. It's there too. So it's not like there's only one way to get all this information. Okay? Max or min? We started talking about that yesterday a little bit. If the parabola opens up, it opens up like this, my vertex is going to be at the bottom. That means my vertex is going to be a minimum. If my parabola opens down, my vertex is going to be at the very top of it. And that's going to be a max. The value would still be the same values as my vertex is. And that'll come in handy when we start doing the application stuff tomorrow. But for now, that kind of gives me my background. So when I get to the graph it part, a couple of different things we've talked about. First one is I put my vertex in the middle. And we talked about how if I'm building my chart and I'm not using the calculator because I don't have one or I want to stay away from that, I add 1 as I go to the right. I minus 1 as I go to the left. Add 1 as I go to the right, minus 1 as I go to the left. And the reason I'm doing it in colors is the 2 red ones will have the same y value. The 2 green ones will have the same y value. So if I wasn't going to use the calculator, what I would do instead, now I'm going to rewrite my equation over here so we can actually see it in the screen as we're doing this, is I, for instance, would take this 2, let's say. Ooh, why am I going to do 2? I see 0. 0 will wipe out this term. 0 will wipe out this term. And just leave me with negative 4. But let's say I get to the next one, I'm like, okay, 3. Pull my calculator up. I'm just going to type in, and everywhere I see an x, I'm going to type in the value. You're like, but couldn't I actually just pull the chart up for that? Couldn't I just do second graph? And if that's in the middle, there's the negative 4 and the negative 4. There's the 2 and the 2. Yeah, I absolutely could. And so that's what I'm up to with these. Okay? And we started to introduce yesterday a little bit this pattern, this +1, +3 pattern that I'd have to multiply by this. So if I was doing the +1, +3 pattern to graph, if I didn't want to do a chart at all, multiply it by a. 1 times 2 is 2. I add 2 to both of these. That's where these had come from. 3 times 2 is 6. I add 6 more. I can get those values. So there's really, really, really a lot of different ways that I can get the values I need for my chart. So this opens up. If I were asked, I already did the vertex, I already did the axis of symmetry. What if I was asked for the domain and range? Okay, the domain, I shouldn't have to think much about at all. It's negative infinity to infinity. Every time, doesn't matter what it looks like. Opens up, opens down, don't care. It's negative infinity to infinity. My range, excuse me, I can either look at my graph and say, hey, it's bottom, which starts at -6, to top, which is infinity, or I can look at my vertex. My vertex y value is -6, and that'll give me the number that I need there as well. Okay? So those are the things that I'm looking for. So all the information's there, just got to be able to use it. Now, on the other side, I threw one twist in. And this can happen now and then, which is why I wanted you to have an example of it. I get to the back. Now, this is a little weird. You're like, okay, first issue. I need to know what my A, B, and C values are. Okay, what's my A value? What number's in front of x squared? Okay, -1. And I look on the end, and I see the 9, but normally we're like, well, the second number is usually b, but it's not here, because that doesn't have an x with it. You're like, well, what the heck? What is b then? Since I have no x value, my b value is 0, and here's why. If I wanted to rewrite this in true standard form, it would look like this. Okay, I've got a 0x in the middle. I have to pay attention to that, because if I don't have my A, B, and C right, none of this is going to go well. Now I'm ready to do my stuff. So my vertex, my x value, the opposite of b, okay, there's no such thing as -0, but I'll play along, over 2 times a. And 0 divided by anything is 0. So now to get the y value of my vertex, I have choices. If I want to use the calculator, I can pull up the chart, get 0 for x in the middle, just write the y value, 9. I could have plugged in 0 for x. 0 squared is 0, plus 9 is 9. Okay, I have options. And then again, making a chart, add 1 to the right, minus 1 to the left. Add 1 to the right, minus 1 to the left. And if you want to use the chart, since it's right here already, use it. So the two values next coming are 8 and 8. And then going out from that, we have 5 and 5. If I didn't have this option, I could just plug the 1 in there. Negative 1 plus 9 is 8. Okay. Or I could even use the pattern. Okay. Negative 1 times 1, I minus 1. 3 times negative 1, I go down 3. It's cool the number of options that we actually have. So, got my vertex. My axis of symmetry, again, make the connections. So 0, 9. My axis of symmetry always goes through my vertex. And it's always an x equals number. You can't just put 0 there. 0 is a number. It's not a point. It's not a line. And axis of symmetry is a line. So we got to put the x equals. My y-intercept, remember, I either can just take my c value. It's 0c, 0, 9. Or I could plug in 0 for x. Get it that way too. Is it a max or a min? Now, some of you are like, well, we haven't graphed it yet. I mean, I got all the numbers. I haven't graphed it yet. I should be able to figure out if it's a max or min before I ever do that. Nicely done. How'd you know that? Yeah, because here, the negative means it's going to open down. And if it opens down, we talked before about how that's going to be a max. So, we plot my other points here. And get that drawn in. And I know it's not on here, but we're going to do one last thing with it. We already know what domain is. Let's do range here. Remember, range is bottom to top. Well, bottom is down forever. So that's all good. Top, two ways to get it. Look at the picture. Use the y value. Oops. Or use the y value of your vertex. So your job with this is to work through the worksheet that was up there with it. Okay, practice K. This is the homework. Date things. Dating things is good. It'll help when we get to homework checks or if you're looking to something. But read carefully. Okay, for 1 through 3. What's the vertex and the axis of symmetry? No graphing. Okay, you do not need to graph 1 through 3. Just find the vertex and the axis of symmetry. For 4 through 7, you got a sheet of graph paper up in your piles. Graph them. Find the vertex. Find the axis of symmetry. So just kind of keep it simple. Now when we get to the back, you're like, whoa, what is this craziness? Okay, what's the vertex form of the following quadratic functions? Okay, now this could send us down a little bit different of a road. So here's how we're going to do this. I'm going to change up the directions here. All right, so here's what we're going to do. We're going to graph. We're going to find the vertex. And I'm just trying to think here for a minute. All right. And we're going to find the range. And the one I'm going to zap, because I just noticed when I looked at this, I didn't put enough graphs on your paper, so we get to zap one of these. So we are actually going to eliminate 12 here. I know the wishful thinking was that I was going to get rid of 10 because there's a fraction. It's okay. It's not going to be bad. And get that knocked out of there. Okay? And since I wasn't nice and got rid of 10 with the fraction, we will zap 12 and 13. I'll give you a 2 for 1 here. Okay? But do work through some of these, because as you get to understand the vertex and the range and how the graphing goes, it's going to make the applications much easier. If you don't do them, it's not going to get any easier. Okay? So try those out.